Space, it's really, really big. When we look up, we see countless stars, but what lies between them? Mostly it's emptiness, a vast expanse of nothing. But this cosmic desert is teeming with wonder. From swirling galaxies to exploding stars, space is far from boring. It's a place of constant motion, creation, and destruction. So, buckle up. Our journey through the universe is about to begin. Imagine a vast, dark ocean stretching out in all directions. Now scatter a few islands across this ocean, each one a swirling mass of light and color. That's what the universe is like on the grandest scale. The islands are galaxies, like our own Milky Way, each containing billions or even trillions of stars. These galaxies are not randomly scattered though. They are clumped together in clusters and superclusters, forming a kind of cosmic web that stretches across the universe. But here's the thing, the space between these galaxies is mostly empty. It's a vacuum emptier than anything we can create on Earth. This might make space seem boring, but it's actually a crucial part of the universe's story. You see, this emptiness isn't static, it's expanding, pushing the galaxies further and further apart. Think of it like baking a loaf of raisin bread. As the dough rises, the raisins, our galaxies, move further apart. That's what's happening to the universe, only on a much grander scale. This expansion is one of the most fundamental discoveries in modern astronomy, and it has profound implications for our understanding of the universe's past, present, and future. So how do we know that the universe is expanding? We can actually observe it happening. Astronomers have discovered that the light from distant galaxies is stretched out, or redshifted. It's similar to what happens to the sound of a siren as an ambulance races away from us. The sound waves are stretched out, making the pitch lower. In the same way, the light waves from receding galaxies are stretched out, making the light appear redder. The further away a galaxy is, the faster it's moving away from us, and the more redshifted its light appears. This relationship between distance and redshift is a key piece of evidence for the expanding universe. But if the universe is expanding, where is it expanding from? Well, it's not expanding into anything. The universe itself is expanding, stretching the very fabric of space-time. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move further apart, just like the galaxies in our expanding universe. Section 4. Hubble's Revelation. The discovery of the expanding universe is credited to astronomer Edwin Hubble, one of the most important figures in 20th century astronomy. In the 1920s, using the powerful Hooker telescope at Mount Wilson Observatory, Hubble made a groundbreaking observation. He noticed that the farther away a galaxy is from us, the faster it seems to be moving away. This observation, later known as Hubble's law, revolutionized our understanding of the universe. It provided the first concrete evidence that the universe was not static, as previously believed, but was in fact expanding. Hubble's discovery wasn't just a random observation, it was based on years of meticulous observations and calculations. He carefully measured the distances to nearby galaxies and compared them to their redshifts. The result was a clear correlation. The farther away a galaxy, the greater its redshift. This relationship is now considered one of the cornerstones of modern cosmology. Section 5. Measuring the cosmos. Hubble's law tells us that the universe is expanding, but it also gives us a way to measure how fast it's expanding. This rate of expansion is quantified by a number called the Hubble constant, often denoted by the letter H with a subscript 0. The Hubble constant tells us how fast a galaxy is moving away from us for every megaparsec, a unit of distance used in astronomy, further away it is. Determining the exact value of the Hubble constant has been a major goal of astronomers for decades. It's a challenging task, requiring precise measurements of distances to distant galaxies. However, the Hubble constant is more than just a number. It's a fundamental parameter that governs the evolution and fate of the universe. Section 6. An expanding perspective. The expanding universe is a concept that stretches our minds and challenges our intuition. It tells us that we live in a dynamic, ever-changing universe. It also raises profound questions about the universe's origin, its ultimate fate, and our place in this grand cosmic scheme. The fact that the universe is expanding has profound implications for our understanding of the universe. It implies that the universe was once much smaller and denser than it is today. If we rewind the cosmic clock, we eventually reach a point where everything in the observable universe was compressed into an incredibly hot, dense state, the Big Bang. The expanding universe also raises questions about the future. Will the universe continue to expand forever? Or will gravity eventually halt the expansion and cause the universe to collapse in on itself in a big crunch? These are some of the biggest questions in cosmology today, and astronomers are working hard to find answers.